Today, we're pulling back the curtain on a piece of technology you've probably seen a million times but never really noticed. It's the unsung hero of our power grid, the thing that makes modern buildings possible, the secondary unit substation.
We're going to be diving deep into the final, and I mean the final, most critical step in electricity's journey. We're talking about how we get all that power from the massive grid safely into the outlets in your office or apartment building. So let me ask you this. Have you ever stopped and wondered, when you're looking at a huge skyscraper or a hospital, how does that insane amount of raw power from the grid get tamed and delivered safely to every single floor?
Well, here's your answer. It's this unassuming gray box you've probably walked past 1,000 times and never given a second thought. This is the secondary unit substation, and it is the absolute gateway for power in pretty much every large commercial building out there.
Okay, so what is it really? The easiest way to think about it is like a self-contained miniature power plant right on the building's doorstep. It has one main job broken into 3 parts. It takes in the high voltage power, it uses a transformer to step it down to a usable lower voltage, and then it distributes that power. And the key is, all that equipment is bundled together in one neat factory-built package. Now, you might be asking, why bother putting this box right next to the building? Well, it's all about one thing: efficiency. The shorter the cables are between this box and the building, the less power you lose along the way. Plus, you get more stable voltage, fewer service interruptions, and it's actually cheaper to install. It's just a smarter way to do it. All right, let's peel back the layers and actually go inside that gray box. We're going to follow the path of electricity as it flows right through the system. So it's like a 3-step assembly line for power. First, it takes control of the high voltage electricity coming in from the utility. Second, the really important part, it transforms that voltage down to a level that's safe to use. And third, it sends that low voltage power out to all the electrical panels inside the building. And here you can see exactly how those 3 jobs line up with the actual hardware. You've got the high voltage section on one side, the low voltage section on the other, and right there in the middle, connecting them, is the transformer. The whole thing is designed to work together as one seamless, coordinated unit. Now let's zoom in on that component in the middle. Because if this substation is a body, then the transformer is absolutely its beating heart. Basically, you've got 2 main flavors. Liquid-filled transformers, which use a special oil to cool everything down. They're super tough and budget-friendly. Then you have dry-type transformers, and just like the name says, they use plain old air for cooling. This makes them way more resistant to fires and explosions, which is why you almost always see them in places where safety is non-negotiable, like schools and hospitals. And you can literally see the difference in philosophy right here. On the left, the liquid-filled one is a sealed metal tank with fins, kind of like a radiator on a car. On the right, the dry type is open. You can see the coils, letting air float right over them. 2 very different ways to solve the same problem of getting rid of heat. But, technology never just stands still. What if you need even more performance, more muscle, and a much longer life out of that liquid-filled design? Well, that's where something called peak transformers come into the picture. And this is where things get really cool. Look at the data. By using a more advanced fluid and better insulation, these peak transformers can handle 12% more load continuously than a standard one. They're also safer in a fire. But the number that really jumps off the page is the life extension. That's right, up to 8 times the expected life of the insulation. That's not just a small improvement, that is a massive leap forward in reliability. It means a much lower risk of failure, which means fewer crazy expensive replacements, and a much more dependable source of power for the building. Okay, so having a super tough transformer is awesome, but real-world reliability isn't just about one component. We got to zoom back out and look at how the whole system is designed, because it's not just the box, it's how all the boxes are connected. So the most basic setup you can have is called a simple radial system. One power line in, one path. It's cheap, it's simple, but it has a huge weak spot. If anything happens to that one power line, the lights go out. End of story. So the next logical step up is the primary selective system. The big idea here is redundancy. You add a second power source from the utility and a switch. Now, if your main line fails, you can just flip over to the backup feed. This cuts your potential downtime way down. But for places that absolutely cannot lose power, think data centers, hospitals, trading floors, you go for the gold standard, the secondary selective system. Here, you have 2 full substations working together. If one of them fails completely, the system automatically shifts its entire load to the other one in just a matter of seconds. This is how you get as close to 100% uptime as possible. All right, for our last section, let's talk about the cool part. Let's look at some of the modern innovations that are making these systems not just more reliable, but a whole lot smarter and safer too.
Okay, so traditionally, connecting the wiring between the different sections of the substation was a super complicated job done by hand on site. This plug-and-play system completely changes the game. It uses factory-made cables with simple connectors. You're basically turning a complex wiring diagram puzzle into something as simple and error-proof as plugging in a USB cable. It's faster and way more reliable.
Here's another piece of smart tech. Think of this controller as the dedicated brain for a dry-type transformer. It's constantly monitoring the temperature inside. If things start getting a little too toasty, it can automatically turn on cooling fans. And if things get really bad, it can even trip the breaker to prevent a total meltdown. It's all about proactive, intelligent self-protection. And this quote right here really just nails the whole philosophy. When all the parts, the switches, the transformer, the distribution gear, are all designed and built by the same company to work together, you get perfect coordination. And for the person who owns the building, that single source responsibility is what guarantees they get the safest, most efficient power possible.
So the next time you walk past one of those unassuming gray boxes, you'll know about the incredibly complex and critical job it's doing inside. And it leaves you with a pretty big question, right? As our world demands more and more electricity with even greater reliability, what's the next big innovation going to be for these essential hubs of power?